This is going to be interesting. Okay. Can they hear us? I think so. Yeah.
We're good.
Alright, we're going to Google Earth. And now I look up Mount Rainier.
Yep, it says view mountain
Rainier.
Okay, so as a group, you're going to type up a document answering following questions that require measurements, drawings, synthesis of understanding of volcanoes. So now we need to find Mount Rainier, Washington on Google Earth. And as a group,
Oh, it's in Washington?
Yeah, that's it. Mount Rainier, Washington.
That's the one in Minnesota or Maryland. It wasn't a very big mountain, so that makes more sense.
Okay, this is the national park.
Yeah.
Okay. So question number 1: use the line tool. Draw one transect from east to west and one from north to south. Make sure you draw your lines following the drainage, the lowest elevation as you come off the main peak of the mountain. Okay.
Right, so I think this is the peak of the mountain. No, it's not. Okay. Where's the peak? How do I know which one the peak is? Because this is a long mountain.
I guess we zoom out. Before it.
Up where? Let me see if I look up Mount Rainier Peak. Very solid. There. That's a lot better. So now we use the line tool.
So
path tool, actually.
I guess we could do the path tool.
Is it the line? Is there a line tool? No, it's not. It's the path tool. North to south. Shout. Oh wait, I forgot. How I'm supposed to do this.
You look at the elevation profile from the east to west transect. Based on what you observe, predict what kind of volcano you would expect this to be. That's the east to west, right?
Mm-hmm. No, this is north to south.
Oh, that's north to south. Okay.
We'll do an east to west one. Is that the one we're answering first? Yeah. Make sure this is east to west. Okay, this is east to west. Yeah. I just hope that's oh crap. I didn't need to do that.
So where do you get rid of that one?
Okay. I'm not sure if this is long enough though. Do I need to go like all the way across? I don't know.
It says following the drainage from the lowest elevation. So as you come up,
I think we're supposed to like.
Oh, do the whole thing. We might need to.
Okay. Let me just delete this one. Delete this one too. Okay. Because this is pretty big. Alright. North to south. Oh shoot. Why do I keep doing this? Why am I doing? Alright, we'll do east to west first. East to west. Yes. Like here?
Yeah. And then across the sea.
Awesome. And then, so what do we answer about that one?
Okay. So look at the elevation profile for the east to west transect. Based on what you observe, predict what kind of volcano you would expect this to be for the first part of
I know, I'm hungry too. Alright, so there you go.
So, based on what you observe, predict what kind of volcano you expect this to be. So what kind of volcano do you think it's going to be?
I think it'll be a.
Is it a composite volcano?
I think it's composite. I don't think it's cinder cone because it's not. It doesn't look like.
Well, and it looked like they had two other little peaks by it, so I'm wondering if it is.
I think it's that one.
Composite?
Yeah, composite. Because I don't think it shoots straight from the top. Because it's not very like, you know. It's not. Like,
wasn't that just a straight one? It kind of has that.
Yeah.
Okay. So composite volcano. Okay. B. Do a screen capture of the elevation profile and use that to create an illustration that resembles the kind of character.
So maybe we
architecture you
should
would
have
expect.
done this in yours, but that's okay. We can just snip it. I'll just snip all these. Wait, we have to illustrate it?
To create an illustration that resembles the kind of architecture you would expect for this kind. Be sure to annotate the label of your illustration. So we got like just a piece of paper and fill it on the back, and then take a picture, and then I can put it in and then send it to you.
Yeah. Let me save this. This is Mount Rainier. Oh, we have one done. Yeah, we can do that. That's that one done. Yeah. Okay, so we got Mount Rainier done.
So then C, compare the elevation profile for both transits created above. Which side of the mountain has the lowest elevation?
Okay, so let's open north to what? North to south. Because it doesn't say look at north to south, does it? It just says look to east to west.
Yeah, but I guess there's something that we're supposed to do.
Ooh, look at this one though. I mean, there are still a little bit of
Kind of like that composite look.
So this one, the lowest point is 1.24. Or no, that's not. This isn't giving us. Oh yeah, this one is 1339, 1338, 1336, 1336, and this one is. Oh wait, east to west. This one's 495.
So north to west has.
Oh wait, no, this is 1534, 1530. 1530.
So, but comparing those, which one has the lowest elevation?
East to west.
East to west. So then, do we just go to number 2 now?
No, we have D.
Oh, D.
What consequences could possibly result on the side with the lowest elevation as a result of that topography? Well, since this is, we considered it a composite, the lava will flow down into that spot. So that's a risk. So the main risk, I believe, is that the lava will flow down into that area.
It's like flow down into different parts of the volcano. Is that what you're saying?
Yeah, like I think if it's the lowest spot, that's where the lava is going to settle. Hope that's what they said.
Okay. So in question 1.1, he predicted the kind of volcano this would be. Based on that answer, what rock types might you find in this area? List all that might apply.
So like rock types as in Like what we went over today in lab, or
That's what I'm wondering. I'm wondering if we would get a lot more intrusive rocks because we have, because if we're going with the composite volcano, the composite volcano, that there's going to be a lot more intrusive because it can cool in that volcano still. Unlike the cinder cone, where it just pretty much comes out.
but I wonder if it's meaning like intrusive, extrusive, or if we're talking about like phaneritic, blah, blah, blah.
So the thing is, I don't think we can tell just from looking at it that way because any of them can still form under.
Because we're gonna get both types. We're gonna have the extrusive and intrusive.
Yeah, but I'm just thinking that the composite will have more chance of the intrusive because it's cooling inside and it can take longer to form the crystals.
But it's definitely gonna do both. Because this isn't gonna just like explode off the top. If it's coming out from the sides too, it's gonna like slowly like.
So we think that it's gonna have intrusive
and extrusive. Because I think all volcanoes have both.
Well, yeah, but I mean, I feel like this one will have more intrusive than a normal cinder block.
Okay.
It's not cinder block, cinder. But
it depends on the area. Like looking at the topography. This is so hard. Because we can't just be like, oh, there'll be obsidian.
No, I'm
Let's just look really close to it. Just kidding. That won't help.
It's snowy. So you can tell it's snow. So you predict the kind of volcanoes based on its rock type.
Well, this gives me nothing. This is very. Oh, that's cool.
But when it says list all of my apply, I'm assuming that they're talking about a lot more rocks. So are we talking about like let's go over here too.
Apparently this was taken in 1994.
So it could have gotten.
I'm trying to go up, and it's not letting me go up. Oh my gosh, I hate Googlers. Hey Googlers, let me out of your grasp. Thank you. So I get the zoom in.
So I don't think it's falsic or intermediate that they're talking about. I think, right? We're not talking about the falsic, intermediate, and like thick or alternative. Because there's no way we can test it because we can't even see them.
No. So maybe it's like talking about like pyroclastic, vesicular. I think we'll see some phaneritic. We'll see some porphyritic, phaneritic. I don't know if we'll see obsidian.
Okay, so we're gonna see phaneritic.
And I think there's gonna be some pyroclastic. No, there won't be pyroclastic.
Do you think there's gonna be some vascular?
Yeah.
Porphyritic, amphibitic, let's see. And where it's just lava out there too, there's probably going to be some amphibitic too. I'm sorry. It's all good. Maybe even porphyritic, amphibitic, because there could be a chance for some of it became the 2-stage. So I think I'll put down those 4 as our main guess right now, our main assumption of what kind of rocks they'd be.
Yeah. Or maybe they're like saying like basalt or.
But how do we know that? We can't test it. That's the
Yeah, I get that.
Do you think there's going to be vascular and amphibitic too?
Yeah, I think these all kind of happen though.
So should I just put all of them down then? Because we're predicting it. We're not.
Yeah. Yeah, I just hope she doesn't expect like take a closer look around at its surroundings. What other geologic features do you notice about this area? Look. Let's see what we notice. Google is hard to work with. It's not. I can't tilt it.
So I got all those down. So take a close look at the mountains and its surrounding. What other geologic features do you notice in this area? So if we were to zoom out, it looks like, yeah, right here, we've got some kind of, a convergent, right? Is that kind of like a convergent happening right there?
Like a convergent plane, or?
Okay, we're right next to, we're pretty close to
the plate.
So we would have a subduction happening. So that's one geological
The subduction zone.
Yeah. So
because if you look out to the coast, you see a subduction zone.
So we have the ocean
to the west.
This creates a subduction zone. And if you think about it, it looks like there's some more mountain terrain on the other side too, which could be a convergent zone happening because there's that subduction, so it's pushing, and so it's making convergence power over there too. Or maybe it's just a bigger mountain range next to it. Like, do you see what I mean right
yeah,
here?
Yeah, I see the
But yeah.
I think that's good
If we
enough
just
for
do that one?
beginners, honestly. Like,
Okay, sounds good.
backing out a ways from Rainier.
So backing it away from Rainier and
Oh, we already backed out that far.
Oh, we were. Is this volcano close to any tectonic? So maybe
Yeah.
what this is asking is, what Jed, we just noticed, it's by a mountain range and ocean. So maybe I should say that, and then we can talk about the.
By other mountains.
Between mountain range and backing out away from mountain Rainier and some kind of questions.
It is near plate.
Okay, right here.
We're on number 4. I need a pencil
It
these are to trick my eyes.
So it is near a subduction.
What is this?
Oh, that's
That's right.
if you need to use it, you can. That was when I was reading.
What's up there?
So it's near a subduction plate.
Or tectonic plate. Yeah, it is next to, what tectonic plate is this? One. No, that's not.
Yeah.
Is that a plate? Oh, it's next to the Juan de Fuca plate.
And what's the other one? North America?
North America? I mean, it's not really a plate though, it's a continental plain.
Oh, okay.
So I don't know if that's it. Well, yeah, North America. I think that's.
So it's between.
I might have that wrong.
Okay, 70%. How much of it do you think is
Mount Rainier's in the Cascades. Okay.
Oh, there's the Cascades.
What kind of tectonic boundary is this? Well, it's definitely.
How you spell
CASCADES.
And then want to go.
CADES. So Cascade.
Wherever the 70 is gonna fall for the all of it.
Um,
And then you're, for the orthoparacene.
I know what direction it's moving. I mean, I can tell that.
20% and 20, that's gonna be, the second line right there. And 10% the other samples just fall with it.
Well, Mount Rainier hasn't blown in a while, but that's probably because this plate is
Do you
moving.
know how far away it is though?
How far?
Yeah, so it's so back to that for A, is this volcano close to any tectonic boundaries? And I'm saying
How far away is it?
Yeah, how far
A couple hundred miles. I would just say a couple hundred miles. Because it's, I don't want to look exactly, but it's like. Yeah, it's probably like a 6 or 7 hour drive.
Okay.
So that would be going 60. Oh no. That's like a 4 hour drive, 3 hour drive.
So
Wait, let me see. I'm comparing my cities. I'm from. Oh wait, no, I'm closer to the coast than this Cascades. I'm like 2 hours from the coast. This is about 3.5 hours. So it's about
So about how many?
about like 200 miles.
Okay.
200, 300 miles.
Okay. So what kind of tectonic boundary is it? Do I just keep answering?
What do you mean, what kind of tectonic boundary is it? Oh, is it like whether they're moving away from each other? So I think they're moving away from each other because the plate is moving away.
Well, it's the subduction, so it's happening. So it's
Yeah, but if you look, like this is moving that way. It's not moving into America. It's moving away. So I think that's what it's talking about. What is it called when they're moving away from each other?
so divergent.
It's a divergent boundary, maybe. So it's moving away from.
So what direction do you think this is moving away to North America? Away.
Yeah, it's moving away. We'll go through these again one more time.
You may have to reference into the moving plates. Do you think there is any relationship between the tectonic setting and the occurrence around Mount Rainier?
I think it was formed when the plate was possibly pushing against Washington.
That's the last one where we.
Oh, whoa, that's a Cascade Range. Look how big that is. It's like it lit up this thing. It's not just. Whoa. Okay, yeah, no. I think that formed when it was pushing against it, because look how far that is.
But I don't think the volcano happened right then. I think it was a buildup.
Yeah. So you think, but wouldn't them pushing away not cause? Or I guess it's just. It's interesting. But it is on it is pertaining to like a fault, like a tectonic plate. So there is a relationship.
Yeah.
Definitely a relationship. The Cascade Range is like along the plate, kind of. So
Yeah.
put that.
So.
Because you can definitely see the relationship, like it's visible. The Hyundai Fuka plate.
I've already mentioned that something. So between the tectonic setting and the currents. We believe that it occurred after I think we could do that. So the cascade is long able to complete. We believe that it occurred after, or I guess during
when the plate was pushing against the Americas, way back when, billions of years ago. Let's see. So
the cascade is long. We believe that it billions of years ago that it occurred billions of years ago when the plates started diverging away from each other.
yes,
So,
or when they were convergent. I think we can ask for clarification.
because like it's gotta be divergent if that's the red going.
Yeah, but I'm thinking it was formed when it wasn't, when they weren't pushing away. It's when they were pushing together. Because when they're, or wait, maybe that would make sense. No, because rifts, when they're pushing away from each other, push up. Okay, maybe you're right. You're right. It is. It's like a continental rift kind of thing. So like it pushes up. But I think I remember.
So do we want to say we believe that it? Oh no, no, I was thinking. So we believe that it occurred billions of years ago when the Cascades
Formed, yeah.
when the Cascades when the Cascades
Formed, like, because they formed along this line, and so like it was just that weakness in the crust or the lithosphere, and then the magma just pushed up.
Yeah.
I'm gonna watch my hands.
So we believe that it occurred billions of years ago and the Cascade formed and it formed during the weakness. So, are there any noticeable volcanoes in this area within a few hundred miles? So, if we zoom out, do we see any?
Yeah, there's one.
How many?
There's
one
a
on the
couple.
other side.
So there's, I think, Mount Adams,
Okay.
and then Mount.
So yes, we do see some.
Yes. Oh, this one actually looks. This is Mount St. Helens. Mount St. Helens is definitely a. It's not like this one. It's a.
Isn't that the common?
It's the one that where the top blows off. I forget what it's called.
You have it on the.
I took it down.
Oh, okay.
I forget what it's called.
It's not the concave. It was like the
It's not a shell. It's a cinder cone. Totally a cinder cone.
Okay.
So like the top just blew off. I did a thing on it.
So are there any noticeable volcanoes in the area? So yes. Within a few hundred miles, what similarities or differences do you notice about them?
Well, one is because we think that this is a composite volcano. So one was a cinder cone volcano. I'm looking up what type of mountain or what type of volcano it is. It's loading so slowly.
So what if it's actually a?
It is a composite.
It is a composite. Sweet, so we are right.
I looked it up and we were right.
Sweet. Okay, so a difference is that it is
compared to.
And so the St. Helens is a cinder cone.
Let me look up, make sure, but I think Mount St. Helens is a cinder cone.
Well, it would make sense because when it exploded, a lot of it kind of destroyed the volcano.
That's true. I think it just said cinder cone, so yeah. Eruptive cone.
Yeah. Okay. So,
So that's a difference we noticed.
is there any other differences we noticed? Is it, well, it's a lot bigger, isn't it?
Mount St. Helens.
Or does it look about the same?
I think we can see where Mount St. Helens go. Mount St. Helens look right here. I think ours looks a little bigger, but that's probably because it is the one that the Cascade is what it's called, because the Cascade like spreads, and this is a lot bigger because
Okay.
it's not just like spewing out the top.
And then the other volcanoes that are closer to the Cascades are to the Cascades are smaller because they don't have as much.
They're not spreading really.
Yeah. Well, what was it? During the plate tectonic one, it was like about the depth and magnitude. Like the magnitude kind of correlated with the depth because there was a lot more depth, there was a lot more buildup of that. So the other volcanoes are closer to the Cascades.
Well, they're all pretty good in the Cascade range. They're not
smaller.
They're not much closer to the plate though. Look, because it's just here, 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 here.
But what I'm saying is, if you zoom in on those ones, they seem smaller than
Yeah,
that.
definitely.
So the volcanoes closer to the Cascades are creating smaller volcanoes because they don't have as much magnitude. Does that sound good?
Yeah, kind of.
Or because they're not as deep.
Yeah.
Okay. So closer to Cascades are creating smaller volcanoes because of depth.
So like
Because
15 minutes. So we'll go back to this again.
well, you can also send me the.
Oh yeah, we can send that now.
Yeah. Okay. So going over this again, we did the line. I'm just gonna bring this up so it's easier to read.
No, why are you doing this?
Just do it one more time, then I'll just exit it.
I'm on.
Yeah, it'll do this to you if you just go. Hey,
We have a question. So we have a question that says like.
This is our group.
Yeah. It's like.
So
What was my question? So we said there's a tectonic plate off the coast of Washington. We're talking about Mount Rainier and like the relationship between the tectonic plate and
that's red, so
Rainier.
it's showing that it's
And we were saying that like there's obviously a connection because like if you look at the whole Cascade Mountain range, like there's a bunch of volcanoes and then the plate's like pretty much like straight along with it. So we said there's a relationship because you can see that the plate and then the volcano is forming in the same kind of line.
So the question.
No, I'm just wondering if that's wrong.
we're not
Great
sure.
statement, Kate. Keep it up. Keep it up.
And then like we said something earlier that I'm not exactly sure. So there's a part, the lowest elevation near Mount Rainier. Is that we said that the risk of that is because that's where the magma will pool and like flow because it's the lowest point.
Makes sense, right? Yeah. Low point.
Yeah.
Water.
I feel like this is just too easy sometimes and then we're doing something wrong.
Sometimes geology is super easy.
Well, I think,
Sometimes it's like. Okay.
and where these are group things that are supposed to be together, I'm pretty sure we're going to try and make it.
Did you put that into the mountain range? Like it's in the Cascades?
We are going. See you Sunday.
Have fun. You're seeing me Sunday night, yeah?
Yeah, we're coming up Sunday.
So
Aaron's probably wondering where I am, so I told her to be there right after 6.
See ya.
I said it's in between mountain range and oceans, Cascades.
Okay, perfect. So what's your email real quick?
It's MIL 05053. Yeah.
Oh, you have a picture.
And I have a picture for one of our classes. So
I changed mine to a
notice.
cat.
Okay.
I feel better after. Like, I guess I just need to slow down this. I'm glad that we're not like a group of 4.
I am happy about that too. Okay, so we have composite volcano for the first one. For the second part for B, we said that.
For number 2,
this
part
is
B?
Part 2, but you're gonna send a picture, and I'll just put it in right there.
Yes.
And then it says compare the elevation. So compare the elevation to east to west. We did that. What consequences?
Yeah, why do we have to do north to south? Oh, because we compared them. That's right.
Yeah. Oh man.
Okay, so this was an easy question, so I feel good about this one.
Mm-hmm.
What kind of tectonic boundary is it? Oh, that was what I should have asked. Oh well, that's fine. What do you think is the relationship to the two cities? Because their line, you see the line of the Cascades, and you see the line of the, like, so you see like the disruption. I think that's obvious. Are there any other noticeable? Yes, there are. Take a look close at the graph, notice in this area. What predicted what kind of volcano this would be. I'm so happy. What rock type? That was weird. We should have asked questions about that.
Oh yeah. And there's what's on that.
Yeah, I know. That was like the worst question. It'll be okay though.
Sorry, I'm having technical difficulties.
Okay, we need to set up like 10 extra minutes anyway. Because we're too good.
I'll send that next PDF.
This is the Romney, right?
Mm-hmm. So I got that. Oh, dang it, it's all right.
This is Control Exit.
Control. It's a 2.
Patience is a virtue.
I don't got patience. Okay, so we have our main risk. We have
Can I ask you a question?
of course.
Yes. Okay. So, where is it?
Is it question?
Okay. So, like, we predicted what kind of volcano it would be, and which we predicted correctly, which I'm proud of. But
we looked it up afterwards.
it says based on that answer, what rock types would you find in this area? So, would that be like talking about like Baneritic, or would that be talking about like basalt, gabbro, diorite?
Because since we're not at the mountain, we can't just grab samples from the mountains. We're assuming that it's the ones that we talked about today. Like,
Okay,
it's
so
gonna be these
you got to give me context. So
Okay.
you had to identify
Oh,
a
let me
type
see.
of volcano.
Yeah.
Okay, what
So
type of volcano?
Mount Rainier is the one we were given.
Okay,
Yeah, which is a composite volcano.
is a composite volcano. Okay, so it's probably more which compositional types of igneous rocks would you
So
find?
like this or like this?
The bottom part. So like felsic, mafic, intermediate, ultramafic.
So like, would you only find like mafic or felsic at one volcano?
Not necessarily.
So I was
Um,
thinking there's going to be a lot more of like the intrusive type because it's building inside more of the volcano. So if you were to dig in it, you get the intrusive.
okay,
rocks.
but you can have intrusive
And
in,
extrusive.
Oh, that's true.
yeah, you can have intrusive in igneous, or not igneous, in mafic and felsic though.
Okay,
Oh,
I don't
okay.
think there's gonna be obsidian.
Obsidian is felsic.
Yes, I don't think there's gonna be obsidian.
Why not?
Because I just don't. I don't know. How are we supposed to figure this out just by knowing like that it's composite? That's so confusing to me.
Composite volcanoes. See, did you figure out the triangle diagram? What'd you get? Lursalite?
Yeah.
Okay,
The
in the
one
top
with
half,
the
in the top
nature?
half of the triangle.
Yeah.
That's what most of them are. Yeah, there's a couple that are dunites, but yeah, lursalite. Lursalite. Imagine there's no H in it. The H throws everyone off. So Lerzolite. Lerzolite. All right, good job. Don't forget to study. Have a great weekend.
So basalt, andesite, dacite, dacite, and rhyolite.
So that's saying that those are the 4 main. But that's from like the molten. Yeah.
Well, magma is molten.
So I'm struggling with these.
So composite volcanoes. Okay, let's think about it this way. This might help to visualize. So composite volcanoes are short and wide or narrow and tall?
Short and wide. Well, this one's pretty narrow and tall. They're not short and wide like the shield volcanoes, but they are shorter and wider than the ones that explode from the top, which are, I forget what they're called.
Because they're wide.
Okay, but they're not like
Shell.
super wide.
They're not shell.
And
No.
shallow. Yeah.
Like in the middle.
They're like the middle between. They're the middle ground between the two.
Right. Okay. So think of like Hawaii would be. Hawaii's a shield volcano, right?
Right.
Okay, which is relatively not very tall, but covers a huge amount of ground.
Right.
Yeah.
Right. Okay. What type? So shield volcanoes. What type of materials come from shield volcanoes?
Pumice. Just kidding. I just know there's pumice in Hawaii.
There
Shield
would be, but typically they're more mafic. So
Right.
what rock type would that be?
mafic is more like gabbro
So
and
the basalt.
Gabbro and basalt. Okay. What is their relative viscosity? Are they high viscosity or low viscosity?
So I read this morning. Well, depending on which one it is, it means they're a thicker rock or a thinner rock.
Oh, they'll be thicker because it's no.
I think it spreads.
Oh,
spreads
so
really
they'll
well.
they'll thin.
So they're thinner. They're thinner and runnier. Okay.
Okay, so if they're thick, they're gonna move like slowly and not so far. But if they're thinner and runnier, so wait, mafic are more runnier.
So me thicker runnier.
So felsic.
So what it is the silica is basically like it's the flour to your cookie dough. So silica, so quartz and quartz materials make things thicker and not as fluid. Okay, kind of like how flour will thicken up your cookie dough.
Right.
Cookie batter, right? So
this is gonna be more like granite and rhyolite.
and probably some andesite and diorite, more towards some intermediate, but more towards the felsic end of things because of the higher silica content.
So do you think we'd get graded down if we just said it's more of the felsic rocks, or should we like be like listing specific things?
If you said felsic,
Well,
I
we
mean,
can-
I obviously I don't know what the
that's
assignment
true.
is.
We're
Not
figuring it out.
this.
you know?
This is literally the complete assignment. This is all the instructions we get.
Yeah. And then we have to video it while we're doing
Yeah, so you're on video. Well, your
voice
both
is.
Oh, yay. Hi world.
Hope you don't mind that.
I don't think they listen to the whole thing. So.
Yeah. Because then we have to give them a summary of what we did. So.
I don't think they have time to listen to 20
Well, if
groups.
he's listening, then he knows the discussion we just had.
Yeah.
So, but yeah, I would
Okay.
yeah, felsic is more where that question is leading, if I understand correctly.
Okay. Felsic due to the fact that they're not running as far out.
Which means they're higher or lower viscosity?
Higher viscosity.
Higher viscosity.
The lower viscosity is like sticky, and this is like adding flour to it, making it slower, and so they have a higher viscosity, so they stick to the mountain and don't just like keep flowing.
Yeah.
Yeah.
Or they solidify it underneath and
Yeah.
build and push everything upward.
Yep.
You got it.
I have bingo arms going. I have close bingo arms. I'm gonna have bingo arms as a granny. It's like when you shake your arm. I mean,
I've never heard that term. I've heard Relief Society arms and softball arms.
Oh.
Never heard bingo arms.
Bingo. How would you describe where the Romney is? Near the Smith?
You could say it's by the Hart Stadium. It shares the Hart Stadium parking lot. That's how I usually describe it. If people are trying to find me, I'm like, oh, it's the Hart Stadium parking lot.
I told my friend to come pick me up here, and he's just like, where is that? I'm like,
You'll find it.
child, calm down.
Oh, this one's mine.
And then it talks about how it's the perfection zone and the divergent boundary.
I just hate looking at this.
The same.
The highlight.
That's so fun.
Because I think we're done in like 2 minutes. Because we started at 30. Yeah. 30-ish. Oh, and how do we turn this in? Let's see.
It should just be.
Are we both turning it in?
Yeah, so I'll send this to you this time. I'll just send it to that email that
Yeah. Just for yeah.
we've done today.
I guess we have like, I guess it's not like a big deal since we have like a whole couple days to turn it in. But I don't want to do it.
It's just nice to get it done right now so we don't forget.
Group activity.
For
I still have to send you the link to the video once we finish it.
yeah, we'll just go back and forth. It's all good. So we're still getting there.
Alright, I'm gonna close the video now.
Peace. Bye.